We're given a table of values with time in the left column and number of bacteria on the right, and we want to find a function that models this data. Now, no matter what the function is, in this case, it's going to end up being exponential. In other cases, it could be linear or quadratic or whatever. At the end of the day, we just need to see which of these functions works with this table data. So we can just test points. Now, I'll show you another way to do it that's a bit more, math classy. But let's just get our answer the way we can by plugging in these points. So for example, when I plug in t equals 0, I should get the value of the function to equal 1,000. And when I do that, choice A fails because 4,000 times 0 is 0. Choice B will work though, and this is why when you do your testing, you need to keep testing all the choices until you have one left. So don't just pick B and move on, because if we look, for example, at choice C I think will also work, right? Because it's 1,000 times 4 to the negative 0, which is the same thing as 1,000 times 4 to the 0, which is the same thing as 1,000 times 1. And so, yeah, that works as well. And as does choice D. We get the same thing. So, yeah, we need to keep testing. Let's try out the next point. So when I plug in t equals 1, I should get the function equaling 4,000. And again, choice B works. Choice C, I think, will fail, though, because we're going to get 1,000 times 4 to the negative 1, which is the same thing as 1,000 times a quarter, and that is not equal to 4,000. So C fails, but D also works, because 1,000 times 4 to the 1 is 4,000. So we keep going. We try our point here. When we plug in t equals 2, we should get 16,000. And finally, choice B fails. But when I plug in t equals 2 here, I get 1,000 times 4 squared, which is 16,000. That's what I wanted to see. And so the answer here is D. Now, is there a way to do that that's a bit more math classy, that's not just plugging in points? Because to be honest, that did take a little bit of time. We got a little bit unlucky with the points that we plugged in and how many it took. We got an answer without needing to know much, but you could argue that that took a bit of time. It was a little bit clumsy. One option to tackling this one is to kind of look at how this data changes. If you look at the t values here, as the values of t go up by 1, we can see first off that these values are not in themselves for the number of bacteria increasing at a constant rate. First goes up by 3,000, then by 12,000, then by a bunch. So this is not linear. And then actually, go back to our choices for a minute, gets rid of A and B for us. Now looking at C and D, you might be able to eliminate C because we just don't typically deal with negative exponents in these exponential forms that much. But you could keep going and say, well, looking at this from a geometric point of view, each one of these values is being multiplied by 4,000, right? Times 4,000, or by 4, multiplied by 4, multiplied by 4, multiplied by 4. So that tells us with our exponential function, we must have some initial value, which we know is 1,000, times that multiplier of 4, and 4 to the t, because as t goes from 0 to 1 to 2 to 3, each time that increments, we're multiplying by an additional factor of 4, which is what we see in the data. And so that gets us choice D. Now, that had its own difficulties, but if you understand how that function is exponential, that can be quite helpful. But otherwise, you can just plug in numbers and see what works.